All right, so today's lecture is ethical considerations in data science. And I'm going to kind of present some principles and ideas and scenarios and present you with questions, but I won't have like answers, and I'm not going to try to say this is the ethical decision to do. This is the right thing and this is the wrong thing. But just because, life is complicated, and you might face a situation where it's troubling. It's troubling in either scenario, right? The classic ethical dilemma is the trolley problem. Are you guys familiar with the trolley problem, where there's like the trolley and it's going on the tracks, and you pull the thing so it kills one person, or allow it to kind of crash into 5 people, right? And then this is just this ethical dilemma, and it kind of just reveals, perhaps different priorities, different ideas, and then almost as a trap for all of these things. It's like, well, surprise, the person you didn't kill was this terrible person, or like, surprise, the person you killed is, was this good person, or things like that. And so anyway, I'm not trying to say like we're going to solve all of these things, but a lot of times you have a problem, you have data, and I think it's good to ask, what are the implications? What is going to happen if I go forward with this project, right? If I go forward with this thing, kind of just like, I think there's always these classical examples in science fiction where, the crazy scientist never stopped to think, should I be doing this, right? Everybody was obsessed with, could I do it? And never stopped to ask, should we do it? And, and then you get these, you have stories like, about Frankenstein's monster, and I don't know, right? So again, not trying to solve any of this stuff. There's clearly, I've got a few examples where clearly some ethical things were violated, but there's also kind of a lot of questions where you go, I don't know. I don't know what the right answer is, okay? Some recommended reading, chapter 8 from our textbook. There's also, there's a fairly long and pretty actually good article on Wikipedia just titled Misuse of Statistics. And I think there's some quotes that maybe tell us how people feel about statistics in general, and how, if you have stats and data, you can kind of, you can always make the data say what you want it to say. And I strongly disagree with that kind of statement, but certainly there have been many cases where statistics have been misused and used to mislead people. That's certainly true. And unfortunately, that has led to a general distrust of people showing charts and diagrams and things like that, right? I think it is healthy to be a little skeptical, and see if you can kind of dig down into the numbers yourself, right? There's kind of as we are entering in this golden age of big data, there's and algorithms making a bunch of decisions and stuff. There is some, I think we're starting to notice that, we can run into problems with this. And there's a book called Weapons of Math Destruction. It's kind of a longer book. And the same author, Kathy O'Neill, has written, maybe a shorter essay that I think you can just look up, and it's available through kind of the O'Reilly library, digital library that I have, just called On Being a Data Skeptic. that covers similar ideas here. Okay, so one thing is just misleading graphics, and these are, I guess, principles that as you create data visualizations, certainly you want to use your data visualizations to communicate something important to the viewer. But when you do this, you should present your data in a way, or present the information in a way that is not going to be misleading per se. Okay, so here's a graphic, and what do we have? It says gun deaths in Florida. This was a graphic that was published in a newspaper. Okay, gun deaths in Florida, number of murders committed using firearms, and then it says right here in 2005, Florida enacted its stand your ground law, and then what happens? We see the number of deaths do what? Okay. Here's the weird thing. They put 0 at the top. Yeah. And so as the numbers go farther down, and we see, so this jump from here to here is actually a sharp increase and not a sharp decrease, okay? And the question is, is it, and so at initial glance, it feels like, maybe it went down, but actually it went up. And, is it even a cause and effect thing? I don't know. But just this certainly, the idea of putting 0 at the top and larger numbers at the bottom doesn't fit normal convention. And so, kind of taking advantage of that in a data graphic probably is not a good idea, right? Certainly, authors of stories and movies and things like that can take your conventional expectations and subvert them, and it makes for an exciting story. Should data scientists try to do that and make have tails and twists in their graphics? Probably not. No, we should present data in a more straightforward manner. This is not our time to try to write a story of that subverts expectations. Okay, so certainly don't do that. Okay, here's a plot. It says this was talking a chart about climate change and how average annual global temperature in Fahrenheit. And what do we see? This line has stayed, if you look at it, it looks like it's fairly flat. It hasn't changed very much from 1890 to 2010 or 2015 or whatever this graphic was published, okay? And the vertical axis, okay, part of the issue is the vertical axis starts at 0 and goes up to 110, which I suppose if you were to looking at places on Earth, you could find places on Earth that were 0 degrees Fahrenheit, places on Earth that were 110 degrees Fahrenheit, maybe even outside of that range. But what do we know? We know that averages don't have as much variation as just individual values themselves, right? So if you're talking about the average temperature for the entire world, it's not going to be as dramatic as going from 0 degrees to 110 degrees or something like that. And so by kind of scaling the vertical axis to be so large, it's easy to kind of miss the general trend that actually if you zoom in, there certainly is an increase and a slope increase that is steeper, in the last 50, 60 years or so, okay? So the scale of the y-axis is misleading, and you should always kind of ask, what is the appropriate scale to use? And the appropriate scale is generally you want to fit the range of the data, but you may also want to consider what is a reasonable range, even if you haven't necessarily observed values from particular values yet. Okay, so but it's a little bit tricky, and certainly things like temperature. Is there a range for temperature? So I don't know, like in chemistry class, did you guys learn about like absolute scales and interval scales and things like that? And so a lot of things, like if you talk about mass, 0 means there's nothing. There's 100, and then there's 200, and 200 is twice as heavy as 100. Okay? If you think about temperature, if you're not measuring Kelvin, okay, then the values don't actually have meaning. Like 200 degrees is not twice as hot as 100 degrees, which is not twice as hot as 50 degrees. Okay, they are the difference between 200 degrees and 100 degrees and 100 degrees and 0 degrees is correct, but it's not correct to say 200 degrees is twice as hot as 100 degrees. And it's not because what is 0? 0 isn't the absence of any heat, right? There are temperatures lower than 0, right? So the only one where it is absolute would be Kelvin, where 0 means there's absolutely no motion in the molecules, and then 200 is twice as high as 100, which is whatever, that's okay. But as far as Celsius and Fahrenheit goes, the 0 is not
absolute,
like a 0 type of thing. Okay, so you can't say 200 is twice as hot as 100. The number's twice as big. Okay, but yeah, I mean, if you think of like if 200 is twice as hot as 100 in Fahrenheit, it should be twice as hot as it is in Celsius, and it's not, right? If you do those conversions, it's not a straight conversion. So, okay, here's another chart, and again, this is looking at like COVID data and stuff, and it goes, oh, it sure looks like it's decreasing. The problem is this is not the x-axis, which measures dates and times. It's not in chronological order. It goes from the 19th of April to the 17th of April to the 22nd to the 20th to the 21st to the 28th to the 24th to the 23rd. It's not in chronological order. So
there's a decrease.
It looks, it's just, I don't know what order they put this in. Probably like they took the average for the day and they did like decreasing averages or something. But yeah, if you have time on an axis, you need to respect that people expect it to be in chronological order, and something like that. Okay, so those are just examples of like, okay, obviously I would say that is unethical. that's kind of a clear thing where you can present your data in a misleading way. And I guess, these are things also to just look out for, when you inspect a data visualization, inspect someone's graphic. These are things that you should ask questions about and things like that. The authors of our textbook say, let's imagine you're in a profession. For doctors have to, a lot of them have to take the Hippocratic Oath. Just the basic idea that in their profession they should not do any kind of harm, right? And so these are some kind of ideas taken from the Hippocratic Oath when dealing with patients, and they come with things like don't be afraid to say you don't know the answer. If you don't know the answer, respect patient privacy, okay, and remember that you have obligations for basically kind of all of your fellow humans, not just yourself or something like that. Okay, and so if we were to say adapt them to data situations, it's okay not to know the answers, right? You will face situations with your data where you're not quite sure what the best way to analyze it is, or things like that, right? the idea of respecting the privacy. Data privacy is a big topic. It feels like every week there's some data breach somewhere, and you as a data scientist perhaps not as intimately involved in like data security. That might be part of your IT security team or something like that. That might fall under their responsibility. But also, just like you might have access to private information, and there are questions of how much of this analysis should you do, and if you publish something, can any of this be kind of traced back to anybody, right? Like, let's say you have private information about people, and there's kind of an outlier in your data that this person has something like that, and people might be able to identify and say, oh yeah, okay, I'm kind of familiar with this thing, and so whoever showed up over here in the data, we figured this out. This has to be this so-and-so person, right? And then they might be able to trace and figure out other aspects of the individuals, okay? And that could, that could lead to issues, right? And this last point, I think, hammers a lot of kind of things that we have to think about when we're dealing with data, right? Is that when we look at the data, a lot of times they're just kind of on our computer. They're in some table or something, and it feels like they're just kind of numbers, and it's easy to get lost and feel like it's numbers without meaning or context. But a lot of times, each of these individual values represents like a real person, and situations and things like that. And you might say, oh, you know what? In my analysis, I couldn't figure it out, so I just threw away these people, and so we're not going to include them. And that decision could actually affect those people, very much, right? So, let's say you're doing some kind of thing, and I don't know, it's like, who should get, our program? How do we allocate our resources? Who should get, help and resources and things like that? And depending on your data analysis, it could result in, some people receiving resources and other people not, which probably is the point. But then you have to really take into account, how do I do this kind of carefully, right? And it is possible that your work may lead to unintended societal consequences, such as inequality, poverty, and other disparities due to algorithmic bias. And so I kind of want to point out some of these things. Let's just have a few discussions of just different scenarios. Our textbook throws in a few scenarios, and I've highlighted a couple of them. I also just put in some questions to think about. Let me go ahead and give you your first view quiz answer today. It's the letter B. B as in bear. B as in bear. Bruin. I don't know. What other letters start off with B? Okay. So there is this, there's a website, datapractices.org. And so these are kind of just some principles that they've listed off as guiding principles. Okay, it says use data to improve life. All right, so basically don't try not to do harmful things, right? You want your data, whatever work you do, you want it to be reproducible. So if people have questions like, hey, how did you come to this result? You should be able to show how you came about to this result, right? You want to be able to say, okay, I found this data and this is what I did, right? Build teams with diverse ideas, backgrounds, and strengths. And so, the idea of if everybody you work with has the same background as you, there's probably going to be you're going to be missing certain concepts, right? You're going to your interactions with the world or whatnot will definitely shape how you think about stuff, and somebody else might have different experience and be able to explain, oh, you know what we're seeing in the data is not just something weird happening, but this is like a real thing. I lived through it. I can understand how we're getting these strange numbers, rather than just saying like, why are these people's numbers so different than everybody else? This is weird, right? And not being able to understand that. Okay. I don't know if I have time to go through every single one and explain all of these in details, but okay. Prioritize continuous collection. So you kind of want to make sure your data is up to date and not just you've collected data once in the past and you were going to assume that this applies for all of future. Identify the questions and objectives that drive each project and use that to guide both planning and refinement. And that's a principle that I want you guys to use in your project, is just have some kind of guiding question in the beginning rather than just going out aimlessly, right? Be open to changing your methods and conclusions in response to new knowledge. Recognize and mitigate bias in ourselves and in the data we use. So as you encounter data, you might recognize that because this data was collected historically, it is subject to bias and things like that. One of your goals as far as presenting your data should be to give people information and empower them to make better decisions with the information that you're presenting. You want to carefully consider ethical implications of any of the choices you make, right, when using the data. And certainly along the way, you might say, okay, in order to help our analysis, we have to get rid of certain outliers. But think, like, these are real people or cases or something that you're throwing away, and what are the implications of throwing away, these observations? Maybe you should be focusing on the outliers because these are the ones that are most in need of something, right? Just not saying, and again, I don't want to paralyze anybody in terms of like, now you have all of this stuff to think about and you can't even make decisions yourself, right? You have to make decisions, but you also want to just be conscious of what are the implications of these things. Respect and invite fair criticism for your work. Protect the privacy and security of individuals represented in the data, and help others to understand the most useful and appropriate applications of data to solve, real-world problems. So, okay, so these are situations that I've copied from the textbook. This one's fairly, easier to understand and less. This is less of an ethical quandary. So this was the CEO's request, and it says a statistician was asked to design a model taking into account some kind of data. There was a publicly available linear regression model. The model was fit to the data, and the statistician said, okay, these are the results of the model. And then the CEO looks at it and goes, I don't really like these results. Can we just kind of tweak it to get the answers that we want? And so what's your response in this case?
How much are you paying me?
Yeah. So I think, in this case, basically the way regression works is it's the way it picks the values and says, okay, this is the coefficient, this is the slope parameter, this is the intercept. It does that by trying to minimize the sum of squared residuals. Okay, there's a certain goal, and it tries to go towards that goal, and that's how it picks the thing, right? And that's generally accepted as a good method for figuring out your slope, figuring out your intercept, figuring out these different values. And that's accepted kind of by the statistical community. And basically the CEO is saying, well, you know what, forget that. I want to do my own thing. And, that in of itself is not necessarily wrong, but, our guiding principles, we want to kind of present our work in a way that empowers others to make good decisions. And so we want to kind of make it clear that if you are doing something else, you're going to end up with basically different results that aren't going to minimize these, sum of squared errors or things like that. And if you're ready to deal with those consequences, fine. Help. You maybe just need to kind of teach the CEO what exactly is happening here. That the idea of kind of just tweaking the model and changing these things to do what you want isn't really, I guess, respecting the data in a way. But is it in of itself unethical or something to do that? I don't know, right? Twitter just got taken over, right? Twitter, they completed, Elon Musk is now the new owner of Twitter. And you can imagine, he's got a different vision for what Twitter should be. And he fired the entire C-suite. And not that the entire C-suite, but got rid of the CEO, CFO, this person and that person, right? And there's probably going to be some people getting promoted, right? Or new people coming in. I imagine there's going to be like, oh, we need to hire a new data scientist that fits what Elon Musk wants to do and get rid of the ones that, and maybe that's fine. Maybe you say, okay, well, I'm taking on this job, so I'm going to do what the new leadership wants. I don't know. What are good, what do we do in that case, right? Here's a different scenario. There's this U.S. Office of Federal Contract Compliance Program. So the U.S. government is this big entity, right? And they often hire private companies to take care of some of the stuff that needs to be taken care of, right? So it's not like, I don't know how to explain this, right? But you might run, some small company with, say, 100 employees, and the U.S. government says, hey, we need you to fulfill this contract, like build us some ball bearings or something, right? And you go, oh, okay, I'll do that. And they have this kind of thing where they want to make sure that all of the companies that they're working with don't have any kind of discriminatory practices when hiring employees. And they currently have a method, and I don't know exactly how this method works, that basically says, oh, you know what, based on the numbers we see for this company, hiring employees, it'll flag some companies and say, you know what, this company might be have discriminatory practices while hiring, right? And that could be a serious allegation, and it's possible that this method yields false positives. I mean, certainly it's also possible that it's going to yield false negatives. And so is it okay that they have some kind of program like this that yields things like this? And so as far as I know, I don't know if any kind of lawsuits have happened yet, but one of the relevant principles here would be, invite fair criticism. The idea of trying to identify if companies are being discriminatory, that's not a bad goal. But how do you go about doing this? And if you just have a simple criteria, right? If you're just using one number to say, okay, your number is too high, it's you're doing discrimination or something. That's probably not the best way to go about. It's kind of just like, should a college admit applicants based on GPA alone or something like that? It's one number that factors in. Should it be the only thing that decides? Probably not, right? And a lot of this comes down to a lack of time and resources to thoroughly investigate every single thing. So whatnot, right? The organization might argue that they're not a statistical organization, so we're just trying to follow the law, and this is what the law says to identify, companies in this way. That's something to consider. Okay, there's another example, and there was some research. I guess some people were doing some research, and they found some faces, images of people's faces, and then they were trying to predict the person's sexual orientation based on an image of their face. Okay, and they say, okay, we looked at this face, and we predict this person is hetero. We predict this person, might be attracted to members of their same sex or something like that. And it could be an interesting question, like, are there certain features or something? But there's also there's a lot of kind of questions of like, is the research problematic in of itself, or what are some of the implications? Okay, and you can imagine, in different parts of the world, the legal status of being in a same-sex relationship is different, right? In some places it's illegal, and you could imagine, I don't know, an oppressive regime getting hold of this kind of research or something, and then implementing it in some kind of dystopian Big Brother type of way, where they put cameras all over the streets, and they say, oh no, based on this we've identified and we're tracking people down and things like that. Certainly, if you wanted to kind of make your data available or your algorithms available and people had questions, how did you come about this? Now there's kind of questions like, okay, do you release this data, right? There's a lot of kind of privacy questions. Perhaps there were people that, aren't out. And so there's a lot of kind of, I don't know, it gets messy, right? And it's always kind of easier to just kind of like, I'm just asking questions. I'm just looking for stuff without saying, and, if somebody wanted to use this for evil, that's not on me, right? Like I just wanted to see if we could make atoms blow up. I didn't intend anybody to use this to kill people. It's just,
I don't like where this is going.
Yeah, no, I mean, it's kind of just like, I just wanted to, and I guess that's part of the problem, is that what you might have started off with good intentions or like an innocent, nothing evil, can a lot of cases be adapted into something for evil. And
artificial intelligence.
Yeah. So, I think we have enough sci-fi movies and novels kind of covering the topic of like AI is going bad and killing people, and but yeah, I think that is a genuine concern that we do have to think about, and I'm not sure what the safeguard is, right? So other scenarios, predicting race based on someone's last name, that could be an interesting question, right? You look at someone's last name, you look at my last name, Chen, and you go, oh, I am assuming he has his ancestry is from China or something like that, and you would not be wrong. And there's kind of that kind of question, but which could be an interesting question, but then could that be misused in a way? And there's also kind of this question: just because it can be misused doesn't mean you shouldn't do it. And I don't know. I don't know what the right answer is, right? Certainly, if someone said, "Hey, I want you to come up with a system so I can discriminate people," you'd be like, "Okay, no, I'm not going to do that," right? But a lot of times it's not as obvious, right? It could be just like, "Oh, here's an interesting question that we have," and then you think, "Okay, we can develop this, but we have to make sure it doesn't fall into the wrong hands," right? And so, you think about, like the, U.S. government and department contractors, they're working on these basically machines that kill, and their kind of practice is they say, well, we're the good guys, so it's okay for us to develop this, and we have all of these kind of things to safeguard to make sure it doesn't fall into the wrong hands. And that's how they kind of deal with the ethical dilemma of, could the things that we're developing be used for evil? And so they've put into place, a bunch of safeguards to make sure it doesn't fall into the wrong hands. And perhaps if you are going to be developing, maybe predicting race based on someone's last name, the extent of that, how much harm can be done, may not be as, dramatic as, developing weapons, but, certainly the development of a sophisticated AI or something that takes into account a lot of data, and you had to be part of that, whoever's in charge might need to make sure that this kind of technology, doesn't get leaked out, doesn't get stolen, doesn't fall into the wrong hands. And, maybe, to work at a place in the research divisions, you need, kind of security clearances, right? In terms of working for the government, depending on the jobs you have to get like security clearances, and they check your background and, what organizations you have ties with and stuff. Maybe we want that, maybe we don't, I don't know. And depending on who you talk to, probably people have different opinions and thoughts on that. There's an example about scraping OkCupid. So OkCupid's a dating website, and you can create an account and you can look at people's profiles. And you can have an app, a dating app, and you just kind of keep swiping. And these are like real people, right? And you'd be like, oh, this is interesting data. Let's kind of scrape this, and let's analyze. And it's certainly an interesting question, but that also violates probably OkCupid's terms of use. They don't want you going and analyzing their data, and probably somebody who's creating, a dating profile doesn't want their information to be downloaded by some random stranger who has no interest in dating, but just like, oh, what kind of stuff are people writing about in their profile, right? I don't know, anyway, there's too many things here. Okay. Here are some questions, right? There's a very real possibility that some of you end up working for a social media site or a tech company or something that some kind of place has an app, and a lot of times the revenue stream, the source of income, the thing that's going to be paying your paycheck, is you need to get advertising money, right? You need advertisers to do on your thing. And so they say, we need to be able to show as many ads as we can to make as much money as possible. And that means making your product as quote unquote addictive as possible. Okay, we want people to stay engaged on our app. Okay, and you have the data to do it. And I don't know. Is this the right thing, right? You think back a couple generations ago to like when there were like cigarette companies and they were advertising, and they said, we just want to make a product that makes people happy, right? We want to give people want this thing, and we just want to give them what they want, okay? And it took the government stepping in and saying, hey, no, this product is kind of bad. It causes health problems, and you can't do this, right? Even though the people want this, you can't give it to them. We gotta wall it off and say, you gotta be a certain age. You can't be advertising. You can't be trying to recruit things. And so, that's still kind of going on with like vaping, and there's lawsuits and stuff like that. And the government just kind of does that with these things. And I wonder if in a few decades, because policy always takes a long time to kind of catch up to, I think, what we already know. I think we already know too much social media is not a good thing, right? For people's brains, I think. And it might be like, oh, this is what the people want. They want to be on there. They want to, I don't know, whatever, spend a bunch of time. But I think we also know, oh yeah, it is certainly addictive. It's certainly not a great thing. But and kind of when we're driven by like, oh, let's make as much money as possible, this is what you're going to get, versus like, does somebody need to step in and say, okay, wait, stop. I don't know. And what's your job, right? You get hired to do something like that, and you go, oh yeah, well, I don't know. Okay. A lot of times you go on a place like YouTube, and it shows you these recommended videos and stuff, and you go like, why are all of these kind of like crazy videos popping up? And it's because, you know what? The quote-unquote algorithm says, oh yeah, you know what? This content had the high amount of engagement. People were commenting, people were sharing, people were doing stuff. And a lot of times the content that generates the most engagement is stuff that's inflammatory. It's stuff that perhaps is not necessarily 100% truthful. And who's responsible for this? I don't know. Yeah.
Could you say that like the creators also play into like this business model? Because
oh yeah, of course. Of course there are going to be bad creators doing stuff like this, but if you're on kind of the platform with the ability to start, you have the ability to basically hand things into people's feeds, right? People's streams and stuff. What is do you have a responsibility in this, or are you just saying, hey, this is what the people want. Let's give them what they want, right? This creator says all kinds of crazy stuff. I don't agree with them, but people like this, so let's give it to them. I don't know what's and there's always kind of like this thing, well, if I'm not going to do it, someone else is going to do it, and they're going to make the money, so it might as well be me. And I don't know. Algorithmic bias. All right, let me give you your last two view quiz answers, but I do want to talk about this. Okay, last two answers are E and D. E as in elephant, D as in dog. E as in elephant, D as in dog. Okay, I don't know if did you hear about this Tay bot created by Microsoft? This came out about, I don't know, 6 years ago or something. Basically, Microsoft created this AI chatbot, and the idea was, you talk to it and it talks back, and it wanted to have conversations. It wanted to kind of have the ability for when somebody interacts with this bot, they have this conversation that feels natural, like they're talking to a real person. And the AI was supposed to learn from other conversations. So it's like interacting with a whole bunch of people, right? And it learns how other people are talking, and it tries to start mimic that back. It's kind of like how a baby learns how to talk, right? It hears the adults talking or the other children talking about it, and it starts saying these kinds of things back, okay? Well, there were some online trolls that said, oh, this is going to be funny. Let's start saying all kinds of crazy, inflammatory, and offensive stuff. And then, and it fed that into the thing. The system took that data in and then started repeating that, right? Started having conversations. It was like, oh, whatever. I don't even want to repeat. Yeah, insert offensive remark, right? And so the bot started repeating these things, and then Microsoft was like, whoa, we got to stop this, and they shut the whole thing down. Okay, so that was an example of some clearly bad data going into an algorithm, and then it starts producing bad results, right? So that's kind of a clear and obvious thing where it's like, okay, your algorithm is going to start, whatever bad stuff you put in is going to start spitting that stuff out, okay? There are cases, however, on the other side, where it's not as obvious, or it's a little bit more subtle about the bad data coming in. And there's a whole lot of things kind of in between, like obviously bad data, and then like, okay, yeah, I can acknowledge there's bad data, but I don't know how to fix this, right? So there's like real estate websites like Zillow and Redfin and Realtor, and I don't know if you've looked for like apartments and stuff, but basically they say, okay, here's this house or here's this apartment and this is how much it's going to cost, right? And you think, okay, well, certainly some neighborhoods cost more than others, okay? And which neighborhood you're in plays a role in the price of the house, okay? If you look at kind of the history of, just a whole bunch of stuff, we can recognize that there were a lot of kind of racist policies in the past that said, if you're a certain race, you're not going to be allowed to kind of live in these areas, or you're not going to be approved for loans to get houses in these areas, and you kind of have to live in certain neighborhoods and some neighborhoods. And even if a lot of these policies have been made illegal today, we see still kind of the consequences of that, and there's still going to be a lot of neighborhoods that have a high proportion of minorities, other neighborhoods with a low proportion of minorities. And if you look at property values, a lot of these kind of neighborhoods that have a high proportion of minorities living in them also tend to have lower property values. And so if you take this into account and you create a system that kind of continues to predict lower prices for these neighborhoods with a high proportion of minorities, is this website perpetuating or exacerbating wealth discrepancies between racial groups? Or is that just kind of what the data shows? And I don't know what the answer is, but this is something that you go, oh, you know what, this could play a role in. And I know I'm going over the time. To get even more complicated, right? You can say, well, what about like neighborhoods and policing, and if you think you're working for a police department, you say, okay, which neighborhoods do we need to send more kind of police officers to patrol and things like that? And you can say, okay, well, let's look at the past data, see which neighborhoods had high arrests and high crime and things like that, and we'd say, and we need more policing in these areas with high crime and high arrests. And you look at this past data, but we also can recognize that the past data could very much be tainted by prejudice, right? And that there might have been, racial prejudice could have played a role into how many arrests were made and who was arrested, right? And things like that. And if you use that data into your system to kind of make more predictions, is that going to kind of just perpetuate some of these problems? And if it is, are there alternatives or solutions? And again, I'm not sure, right? There's an article about using AI. This is you can read this about China using cameras and their AI systems to kind of identify or do racial profiling to identify Uyghur populations and things like that. So just kind of interesting stuff, kind of playing a role, and I guess it's good to think about these questions and not just go blindly. Okay. We'll end here for today. Have a good and safe weekend. We'll see you all on Monday for Halloween, and we'll see you then.
Thank you, Bob. Have a good weekend.
All right. Have a great weekend.